An important part of project management is to use a methodology, especially in relation to software development. For this, we often use the term of the SDLC. The SDLC can mean either system development or the software development lifecycle. There have been a number of different versions of SDLCs put forward over the years, and really they all have the same common objective, even though they may use different phases. In times past, we used to use a distinction between the SDLC, which really referred to the system while it was in development, and the systems life cycle, which would then include the maintenance and operational phases of the system. But today, we normally use the term SDLC for the entire system life cycle, from the day when it was first imagined as part of project initiation, right through its development, operation, until the day of its disposal. The SDLC is really just a project management technique to help us manage then and control the software development process. The idea of using a proper project management technique should increase the likelihood that this project will actually be successful. Project success would be measured in delivering a project that meets then the user expectations. It is able to manage and maintain a level of project quality. Project quality often referring to the fact that the project is useful, as well as, of course, that it operates in an effective way and can support then business operations. There are many reasons why we need to make changes to systems. We have, of course, existing systems and processes, and yet we look at replacing them or upgrading them. Now, this could be because we're going into a new line of business. We're going to deliver a new product or service we had not previously delivered. It could also be because we need to make enhancements or improvements to our existing software. Added functionality, for example, maybe make it more efficient. It could be that we need to meet new requirements for reporting or compliance. And in this way, we have to build our systems to address then what the regulations are. These regulations often require us to do monitoring and logging to be able to ensure that our systems are actually then meeting the regulatory needs as far as data retention and tracking the various activities on the system. There can also be problems we've discovered with existing software or even business processes. It could be that we've found some bugs or vulnerabilities that have to be addressed. We could even have some new threats that have come along as well that we need to address then through enhancements to our systems. There also, of course, is the opportunities that are provided through new technology. New technologies that is available to help us to do things we couldn't do before or to be able to do them more efficiently. So we designed the change through a project. Now, obviously, the goals of a project are to meet the clearly defined deliverables. And that, of course, makes some of us laugh hilariously to hear a comment like that. Because one of the problems with nearly every project is what are the clearly defined deliverables. One of the most difficult challenges we face in systems development is really understanding what the business needs. That may not be the same as what they're telling us. And it could well be that these clearly defined deliverables and requirements we had at the beginning of the project are substantially different from what the business actually describes later on as the project's in development. But we need to become artists at gathering requirements. We have to learn how to discover the user needs. We have to learn how to develop creative solutions to those needs. And it's important that as much as possible, we have a goal in mind. We have a vision of what this system will do, so we can work towards that goal. Project management is not about using resources. It's about using resources effectively towards a clearly defined objective. In order to do this, we need to involve all of the stakeholders. A problem we often have is that project requirements were based on the needs of one group, and maybe that is the dominant group, but it did not consider the needs of the other parts of the organization that also interacted with this system. We see too often we develop a system for one purpose without looking at how that system interacts and is dependent on other systems. In many cases, we should not be just replacing a system. We should be building an architecture of many pieces that come together towards a common goal. This means we need to understand the needs of all of the people affected by this system from different departments, as well as even from our IT. A problem that's often made is if we build a system that's completely unique, it's going to be very difficult for the IT department to be able to operate and maintain that system effectively. No, we need to build things that fit together with what we already have as well. Another traditional problem are realistic timelines. The problem here is that we tend to be optimists. Even for myself, my boss always used to take any proposal I gave him for delivery and he would always double it. And I would say, no, I've tried to build in extra. He said, no, but I always know with your case, you're an eternal optimist, I'm going to double it. And that's what he did. And maybe he was very right. In most cases, there were lots of unforeseen problems that came along. And that timeline that had been developed, we can say, with best intention, in the end, quite simply, was not realistic. We know that in life, there's always unforeseen challenges that will come. And as auditors, we have to be a little bit skeptical. We have to look at something and say, is this really realistic? Is everything that we're doing based on a best case scenario when we know in reality life is rarely a best case? So what is our role as an auditor in the SDLC? Well, we want to get involved as early as possible because systems projects are going to deliver at the end, but the delivery at the end is dependent on everything that was done before then. So the earlier we are involved, we can hopefully provide that objective and in some cases balanced view. We review the project documentation to see whether or not the feasibility studies, the cost-benefit analysis, and the initial considerations of what to do as far as build, buy, improve, replace, were all based on, should we say, realistic and tangible data instead of just hopes and aspirations. We review the project status on a regular basis to see if the project really is on course. In the early stages of the project, there can seem to be tremendously fast developments. But it's in the later stages when we get into the details that things really slow down. And it's at this point often that if we've not been efficient at the beginning, there's no way we're going to be able to meet the timelines when we get into the very detailed work that needs to be done later on in the project. We need to make sure that our systems are robust, they're resilient, they will be attacked. And so we have to build a system that will work in its true operational environment. We have to understand the threats. We need to understand the possible risks that our system will face when it's in operation. And many of those risks may be intentional, but many of them will be simply accidental. A user put the wrong data in the wrong field. So as an auditor, we need to make sure that our test plans are complete. An important part of audit is to make sure that the test plans we've put together will test all of the elements and all the possible variables, so that there is not a chance that a system will be compromised from something we simply didn't test for. The other thing is, usually when we begin auditing a system, one of the first things we'll do is see whether or not the developers actually did what they were told to do. In other words, is the as-built the same as the as-designed? Now, it could well be that the as-built is different because of legitimate and approved changes. But in many cases, it could just be because the developer was, cutting some corners and didn't feel like doing all of this extra work. We see that a majority of the breaches of applications come through preventable errors. For example, many of the breaches with web applications can be traced back to a failure to do proper input validation. But input validation is a rather difficult task for a developer to do. When a developer is going to then turn around and have to do input validation, there are a number of extra lines of code they have to put in place, not only to check the input, but also to handle any errors. That makes a lot more code to code and a lot more to test. The other thing is that input validation should be done both at the client as well as back at the server, because anything that is done by the client could be manipulated or changed by the client. So just to do input validation of the client is not sufficient. As an auditor, we need to check and make sure that all of these extra things were actually done, and of course that they're documented, that the actual documentation is of the system as it's built, not just as it was originally designed. Many projects are based on assumptions. We assume that this will be available, or we're making an assumption about whether or not we're going to do this within scope. And again, as an auditor, we should have what we saw in the first chapter, what we call a professional skepticism. Are those assumptions really valid? There can be a number of cases where a project assumption was really based on, shall we say, not really accurate or realistic information. And that assumption then could cause the project to fail later on.